Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the equations of parallel and perpendicular lines. This is part one of a two-part lesson. Before we get started, let's review a little bit about what we remember about parallel and perpendicular lines. First of all, parallel lines have the same slope, but different y-intercepts. So for example, if you had y equals 2x plus 5 and y equals 2x minus 3, you wouldn't even have to graph those to know that they're parallel lines because they both have the same slope and they have different y-intercepts. Now, we also know that parallel lines never intersect, and their symbol looks like two parallel lines. Perpendicular lines have slopes that are opposite reciprocals. So an opposite reciprocal would look like if you had positive 3 over 2, the reciprocal would be 2 over 3, and the opposite of positive 3 over 2 is negative 3 over 2. Okay? Is negative 2 over 3, excuse me. If I had something like negative 5 over 2, the opposite reciprocal would be positive 2 over 5. Okay? Perpendicular lines always intersect at 90-degree angles, and their symbol looks like an upside down T. All right. Now, let's practice finding parallel and perpendicular slopes. So if you're given an equation and you're asked to find what would the slope of a line parallel to the original line be or perpendicular, you must first find the slope of your original equation. So to do that, we'll rewrite these equations in slope-intercept form because we're trying to find the coefficient of x. So we have to get the y by itself. So we'll start here by subtracting 3x from both sides to give us 4y equals 8 minus 3x, and then divide by 4. So that would give us y equals 2 minus 3 over 4x. Now remember, we said the slope is the coefficient of x. So this slope of this line is negative 3/4. So the parallel slope must also be negative 3/4. But the perpendicular slope is the opposite reciprocal. So the opposite of a negative is a positive. And the reciprocal is 4 over 3. All right, let's try the next one. 5y minus 2x equals 10. So I'll start this time by removing the x. The opposite of negative 2x is positive 2x. I'll add that to both sides. So 5y is equal to 10 plus 2x. And then divide each term by 5, which would give me y equals 2 plus 2 over 5x. So this time our coefficient of x is positive 2 over 5. So our parallel slope must be identical to the original slope. Our perpendicular slope, the opposite of a positive, is a negative, and the reciprocal of 2 over 5 is 5 over 2. All right, next problem. Start by removing the x, so subtract x from both sides. So negative 3y equals 12 minus x, and then divide by negative 3. So this would be y equals negative 4. Now be careful here because this is an understood 1. And a negative 1 divided by negative 3 would be positive 1 over 3x. So our original slope is positive 1/3, which means our parallel slope is also positive 1/3. But the opposite of a positive is a negative, and the reciprocal is 3 over 1, which we don't usually leave it like that. We usually reduce that to negative 3. Okay. All right, now that you understand how to identify parallel slopes and perpendicular slopes, let's try it if we're given a graph. In our first example, we were given equations. In our second example, we're going to be given a line for our original equation. These are actually much easier. All right, so in example 2, a linear function is shown below. Sketch two new functions that pass through the point P such that g of x is parallel to f of x and h of x is perpendicular to f of x. So first of all, we have to find, just like we did in example 1, we had to find the slope of the original line. We have to find the slope of this original line. So let me find two friendly points here. How about this one and this one? Starting with the bottom, we're going up 2 and right 3. So our original slope is 2/3. All right. If our original slope is 2/3, we know, let's see what they told us about g of x. G of x is parallel to f of x. So that means g of x, because it's parallel, let me grab a red pen, must also have a slope of 2/3. Now, it told me h of x is perpendicular to f of x. So for h of x, the opposite of a positive is a negative, and the reciprocal of 2/3 is 3/2. Okay. Now, the next thing we're going to do is sketch each one of those lines. So I'm going to sketch g of x first, and g of x has a slope of 2/3. So start with point P, and I'm going to go up 2, right 3. I can't go any more that direction, so I'll go the opposite way, down 2 and left 3. So 1, 2, 1, 2, 3. Okay. And I will label this to be, oh, I really wanted to make that red. Let me just color over that and make these little points red. This is g of x. It is parallel, and it has the same slope of 2/3. Okay. Now I'm going to make a new line. I'm going to make it pink. I also want it to start at point P, so let me fill in point P again. But this time, I want this new line to have a slope of negative 3/2. So it's going to start at point P and go down 3, 1, 2, 3, right 2. I can't go any more that direction, so let's go the opposite way. Let's go up 3 and left 2. So 1, 2, 3, left 2. 1, 2, 3, left 2. Now let me draw that line in. Now what I want you to notice is that it intersected the original line at a 90-degree angle. So let me label this h of x. So there's a parallel line and a perpendicular line. All right, example 3. A linear function is shown. Use the graph to answer the questions. So question A says, what is the slope for f of x? In other words, it's just asking you to find the original slope. So I need two friendly points here. Let's use this one. Oh gosh, and maybe this one. So start with the bottom, up 1, 2, 3, left 1, 2, 3, 4. So negative 3/4. All right. So now that we've got our original slope, it says sketch and label two new lines, g of x and h of x, such that g of x passes through the point 4, 5, and it's parallel to f of x. So if it's parallel, it must also have a slope of negative 3/4. So I know the equation is going to be g of x equals negative 3/4x, either plus something or minus something. That's what we're going to try to find. So our starting point is 4, 5. So let's put a dot there. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so there's our starting point. And I want to use my slope, negative 3/4, to make a new line. So go down 3, 1, 2, 3, 1, 2, 3, 4. So down 3, right 4, I end up there. Now let's go the opposite way. Up 3 and left 4. 1, 2, 3, 1, 2, 3, 4. It ends up right there. Now that's important because now I know where it touched the y-axis. In other words, I know, whoops, I didn't want a highlighter. I wanted a pen in red. Now I know the B. And when we're writing equations, that b is a very important point. So where did it touch the y-axis? 1, 2, 3, 4, 5, 6, 7. It touched it at plus 8 or positive 8. Okay. Now let me grab a different color of pen. I'm going to use pink. This time I want my point to start at 3, 2, and I want it to be perpendicular. So if it's perpendicular, the slope must be positive 4 over 3, the opposite reciprocal. So I know the equation for h of x is going to be positive 4 over 3x plus something or minus something. All right, so let's get my beginning point, 3, 2. 1, 2, 3, 1, 2. So there's your beginning point. And I want to go up 4, 1, 2, 3, 4, 1, 2, 3. And now I'll go the opposite way, down and left. So 1, 2, 3, 4, 1, 2, 3. Perfect. I now know the B. I know where it touches the y-axis. So let me draw in this line here. And that is, let me label it h of x. And by the way, I forgot to label my first one as g of x. All right. Now, what I want you to notice h of x is it does intersect the original line at a 90-degree angle. And where does it touch the y-axis? At -1, -2. At -2. So now I wrote the equation for the parallel line and one equation for the perpendicular line. All right, example 4. A linear function is shown below. Use the graph to answer the questions. So the first thing you always do is find your original slope. So let's see. Let me get 2 friendly points here. I'll use this one and this one. 1, 2, 3, 4. Right 2. So 4 over 2. That would be a slope of 2. Okay. So now we've got our original slope. Now we can draw our 2 new lines. Okay. So let me change to red here. G of x is going to pass through the point -4, 3. So let me plot that. 1, 2, 3, 4, 1, 2, 3. So G of x is going to start right there. And it is perpendicular. So if it's perpendicular, I need the opposite reciprocal. So if you think of 2, if you think of my original slope as 2 over 1, the opposite reciprocal would be -1 over 2. Okay, so I want to start at this red dot, -4, 3, and go down 1, right 2, down 1, right 2, down 1, right 2. Now that's really all I need, because I was just trying to figure out where does this line touch the y-axis. All right, so when I write my equation, g of x is equal to -1 over 2x, and then it touched the y-axis at +1. All right, now let me change to pink for h of x. H of x starts at the point -2, 4, and it is parallel. Parallel. So if it's parallel, it must have the same slope as the original, which is 2. So I know h of x is going to be 2x plus something or 2x minus something. So let's put our original point, -2, +4. That would be right there. It's your original point, and it has a slope of 2, which I might want to write it over 1. So it's going to go up 2, right 1. 1, 2 over 1. 1, 2 over 1. Bingo. I found what I needed, because now I know where it touches the y-axis. Let me label this h of x. Okay, so it touches it at 1, 2, 3, 4, 5, 6, at +8. So now I have my equation for h of x. All right, pause the video and try example 5 on your own. All right, welcome back. Let's see how you did. So I got the slope of the original line to be positive 3 over 5. Then I sketched g of x. Let me change to red here. G of x passed through the point negative 5, 1, 2, 3, 4, 5, 1, right there. And it is parallel to f of x. So I know that g of x, because it's parallel, would be 3 over 5x plus something or 3 over 5x minus something. All right. Now let's use the slope, 3/5, up 3 and right 5. So 1, 2, 3, 1, 2, 3, 4, 5. Bingo, I just found what I needed. I now know where it touches the y-axis. So let me draw in this line. This is, excuse me, not h of x, it is g of x. It touched the y-axis at 1, 2, 3, at positive 4. Right? Now I'm going to sketch a new line, h of x. And h of x starts at the point 3, negative 6. So 1, 2, 3. 1, 2, 3, 4, 5, 6. And it is perpendicular to f of x. So that means the slope must be the opposite reciprocal, or negative 5/3. So it will be negative 5 over 3x plus something, or negative 5 over 3x minus something. So I want, well, I can't go down 5 and right 3. I would go off the grid. So I'll go the opposite way. I'll go up and left. So 1, 2, 3, 4, 5. 1, 2, oh, bingo, I hit it right there. This is where it touches the B, the y-intercept. So let me sketch that in and make sure it's perpendicular. Yep. It crosses f of x at a 90-degree angle. So here's h of x. And it touches the B at negative 1. Now, if you missed any part of this answer, please pause the video and correct anything you missed before moving on. And that concludes today's lesson, Equations of Parallel and Perpendicular Lines, Part 1.